Hello students, so we shall be talking about transducers in this lecture. Now, these transducers are basically devices for converting non-electrical signal into electrical signal, or vice versa, or electrical to non-electrical, or non-electrical to electrical signal. The variations in electrical signal being a function of the input. That's important thing. The variations are the function of the input. And these transducers are used in measuring as measuring instruments in electroacoustic field, electroacoustic and like in the case of gramophone pickups. Example is they are also used in microphones and loudspeakers. Now, the physical quantity measured by the transducer is measured, and the portion of the transducer in which the output originates is the transducer element. So we have the output is basically related to the transducer element. Now, the different electrical phenomena employed in transduction are as follows. For example, we can have a resistive phenomena, we can have an inductive phenomena, have a piezoelectric phenomena, we have a photoelectric, we have photovoltaic, potentiometric, capacitive, electromagnetic, ionization, photoconductive, thermoelectric, and frequency generating. So these are the phenomena associated with the transducer. Now, coming to understand the working of a transducer, we need to first understand the vacuum system. Now, as it is related to the pressure, so first we need to find out the expression for the pumping speed of vacuum system. So pumping speed of vacuum. Now, if the quantity of gas is mv PV, and we have PV is equal to nRT, and then we can write this again is equal to mv by m RT, where this mv is the mass of the gas in the volume. Then and capital M is the gas molecular weight. So you can write UV is equal to PV by M by RT. Now, the pumping speed is basically dV by rate of change of volume with time at a constant pressure, and pumping time obtained by change in the mass of the gas, which is equal to d by dt of PV, and it is equal to minus S by V, P minus PD. P minus PO. So ultimately what we get expression P is equal to PO exponential S by V into T. Expression of pressure where T is the pumping time. This T is basically the pumping time. Now, pressure transducers convert the physical variable pressure in electrical output. So as the name suggests, so they are converting pressure into electrical output and this is proportional to pressure measured. The output may supply a current or voltage signal. So this output is basically we get as a voltage signal. Standard signals allow to combine transducers, controller and computers or stored programs of different manufacturers. Now the differential pressure transducer with the capacitive measuring cell. So we take a case, we call it differential pressure transducer with capacitive measuring cell. Now this differential capacitor is a precision transducer. And is highly accurate. Is noise free. And stable lowest pressure. Due to design, this differential capacitor is not yet destroyed at differential pressure of 1 bar. There is another transducer called atmospheric pressure transducer. With capacitive measuring cell. Now this transducer it measures atmospheric pressure from the norm itself we can understand. Now, considering the structure of transducers is something like this. We have a chamber, two different colors here. There is a chamber like this. And attached to this chamber is two valves. This is called the roughing valve, and this one is called the backing valve. The two valves, and this is and attached to the pump. This is where the pump is. So, this is the pump. And we have the high vacuum pump here. We call it HVP, high vacuum pump. And this is the inlet valve. And there is something called a cold trap. Okay, so this one is called the cold trap, and this of course is the chamber as told earlier. We have seals here. So this is how a pressure transducer looks like, or a vacuum system looks like used in a pressure transducer.